right. Hello, geometry guys. Um, Here's the next section. Algebraic proofs. These are so much easier than writing paragraphs. I will go back and we'll do one or two writing paragraphs and looking at postulates. But I want to move on and talk about properties of equality. You have learned these properties before. You just may or may not have remembered their names. So let's go ahead and look at each property of equality. Property of equality for addition says if A equals B, then A plus C equals B plus C. Well, you've done that before, right? When you've had an equation that looks like x minus 4 equals 6, and you've added 4 to both sides of an equation, that's the addition property of equality. So you've done this before, right? The same thing holds true with the subtraction property of equality. If you subtract the same amount from both sides, then everything stays the same. If you multiply both sides by the same amount, again, everything stays the same. And of course, the division property of equality. So you have taken care of these guys, and you know what they're called, or I hope you know that that's what they're called. They're properties of equality. Whatever happens on both sides, as long as it's the same, everything stays the same. The equation stays the same, or you have an equivalent equation here. It's what we use to solve equations. The reflexive property of equality. Well, reflexive just means it's like you're looking in the mirror, right? So 5 is equal to 5. Well, that's just the reflexive property. That's just what it is. The symmetric property. This is a fun one, the reflexive property. A is equal to B and B is equal to A. So if you say x plus 3 equals 3 plus x, you would say that that is the symmetric property, because it's like there's a mirror right here, and this is just the reflection in the mirror, right? Okay. You could also, move on, and we're going to talk about the transitive property. That was that fun thing that we've just been taking care of. So I'm going to move some of this. Well, yeah, I think I'm going to get rid of this, and then I'll show you the transitive property. Or we've already talked about the transitive property, but hey, this is if angle 1 is equal to angle 2, and angle 2 is equal to angle 3, then angle 1 is equal to angle 3. And instead of writing a paragraph about it, for this part of our exercise, we're just going to write what that property is. Okay, we're going to solve equations algebraically. We're going to show what the property is. The substitution property just means that you can substitute for whatever in any equation or expression. So if I have, x plus 6, and over here I say, well, x is -1, well, then I can substitute -1 over here for x. And then I can say that -1 plus 6. That's substitution. You can substitute it into an expression. The distributive property, we can do substitution with sums and differences as well, but we'll get to that later. The distributive property, obviously, if you have 3 times x minus 8, then the distributive property says this is the same as 3 times x minus 3 times 8. Right? And you would say 3x minus 24, and you'd be right. That's using the distributive property. So let me, once again, get rid of all this, and we'll move on. I'll move to this layer here, and here's just an example of what's going on. So I'll use a dark color so you can see it. The first thing you're going to do when you're writing justifications for solving equations is first restate what is given. I like to use the word given. Oops, sorry. I like to use the word given instead of writing the original equation. You can write original equation, you know, whatever. OG equation, whatever. Blah, blah, blah. And then what did we do first? The first thing, what changed? Well, this changed right here, so they used the distributive property. Right? And you're just telling me what was happening, what has happened. We decided to put like terms together. So this substitution property, substitution can be like terms. So where's substitution? Right here. I'll put a little def over here, a little definition for you over here. And I'll say combining like terms. Like terms is substitution property. Okay, so now we have another definition of the substitution property, and there it is. It's right there. Now, what did we do? We had to undo this subtraction with addition. I don't know why they do it horizontally. I hate that, but you know, they're a textbook and they have their own method. I wouldn't write it like this. I would put the +2 underneath and keep going vertically. Anyway, they've added 2 to both sides. Well, what is that? Well, that's just if you've added to the same amount to both sides, you've used the addition property of equality. I guess when you put things together, when you finally do the math and put it together, then now you have substitution. Why? Because we substituted a 32, because that's the same thing as 30 plus 2. All right, so we've used the substitution property again. Sometimes we forget this step right in here. Not necessarily a big deal, but it's nice to know that it's there. Second to last, what did we do? We divided by 8 on both sides. That's the division property. And x equals 4. Again, we've just done the math. So substitution combining like terms or doing the math, you know. So I can put this up here. I'll put another arrow up here. Substitution property also means doing the math. And really it is combining like terms, because these are like terms, right? These are whole numbers, they're like terms. Doing the math. Operating. Not the moth, the math. There we go. All right. So we got that taken care of. We're going to move on. We're not going to do, we're not going to just look at the example. We're going to do some of it, right? So let's go over here. All right. And we're going to write right on this sheet here. So you have this given equation, 4 4x plus 6 over 2 equals 9. Prove that x equals 3. Okay, well, we'll prove it. And what's the first thing we do? We restate what is given. This is going to be common for everything we do. Next, we're using the multiplication property, and we're trying to undo this division, this fraction under here. So what are we going to do? We're going to multiply by 2. I don't know why that minus sign is there. I think it's supposed to be an underline, and you're supposed to put the 2 on there. Or, oh, I see what they're doing. Okay. I apologize. They want it up high, because you could say it's 2 over 1. Right? They don't want you to get confused and multiply your denominators so that this can cancel with this. Right? Okay, now I get it. Okay, that's the multiplication property. Now, what did we do? We just did the work, right? And we put these together. So we used the substitution property. We did the math, right? And then what are we doing? We're trying to get rid of this 6 here, so we subtract 6 on both sides. So it's the substitution property. Subs, because this is subtraction. That's the subtraction property. Again, with substitution, we're going to do 18 minus 6. So 18 minus 6 is 12. Right? We did the math. And then what are we going to do? We're going to divide both sides by 12. So this would be 4. Divide both sides by 4. Oh. So we'd just write out 12 divided by 4, and that's the division property. And last but not least, we will do the substitution, which is just doing the math. 12 divided by 4 is 3. And now we've proven that x equals 3. Awesome. Let's try the next one. The next one is another fill in the blanks. All right. It says, given 4x plus 8 equals x plus 2, prove that x is negative 2. So here we go. We're restating what we've been given. So what do? We just write the word given on this line. All right? And then we look to see what happened, what operation was performed here, and we're subtracting an x from both sides. I know they had to hit the return button and move this whole thing down for some unknown reason, and I'm sorry it looks like that. We're subtracting x from both sides, so we are talking about subtraction. Next, we just did some math, right? We put our negative x and our 4x together. We got 3x plus 8, and then x minus x goes away. We've done the math, so we've done substitution. What's next? We are going to 3x plus 8. I'm going to do it my way. Minus 8 equals 2 minus 8. Look at that. I can make it work. 2 minus 8. So we have 3x. And then in the substitution, on the substitution line, we're just going to do the math. What's 2 minus 8? Well, 2 minus 8 is negative 6. Right? So we have 3x equals negative 6. Then what happened? Well, we used the division property of equality. Division prop. And that just means we divided both sides by 3. And then we're going to use substitution by doing the math. That cancels out. X is equal to negative 6. Divided by 3 is negative 2. Hey, look at that. We proved it right. Pretty good? Look at how easy this was. Now, I'm going to get rid of this. We have just a couple more things to talk about. The coolest thing is we've already talked about the transitive property, and here is the picture of it right here. If AB is equal to CD and CD is equal to EF, then AB has to be equal to EF. There it is, the transitive property written out for all of us algebra folks to see. I think I wrote this on the board. I've written this probably 3 or 4 times. If angle 1 is equal to angle 2, I wrote it earlier. Angle 2 is equal to angle 3, then angle 1 is equal to angle 3. What else? Reflexive. You just put the same thing on both sides. The same exact thing on both sides. Symmetric. This is kind of fun. Symmetric is just you take AB equals CD and then you flip-flop the sides of the equal sign. So now CD is equal to AB. You haven't changed anything except you've just switched the sides. 1 on the left, 2 on the right. Okay, symmetric would be 2 on the left, 1 on the right. Cool? All right. Now that that's over with, I got to leave that up. But I want to put this out there. Here's the example that they use. Again, transitive property, right? You have a statement that's given. Angle 1 is equal to angle 2. Angle 2 is equal to angle 3. Prove that angle 1 is equal to angle 3. So the biggest problem with this side of the page is it takes a little bit longer for a simple statement. Like you could have just said, hey man, transitive property. But in algebra, in geometry class for proofs, you pretty much have to write everything out individually, like they did here. The first part of the statement, angle 1 is equal to angle 2. Given. Now, the second one, the second statement, angle 2 is equal to angle 3. That's a given. Therefore, angle 1 is equal to angle 3. Transitive property. Good? Great. Let's do some. Right? Now, if we really wanted to write this out, we would say, for this one, 1. I don't have enough space over here, so I'm going to do some of the work over here. We'd say angle 1 is equal to angle 2 given. And then I'd say angle 2 is equal to angle 1. And instead of writing given, because I only have the two statements, the statement and then what needs justification by way of property, well, look, AB and AB, are they in the same order? No. Are they reflecting on each other? Has the order changed? Yeah. So we're talking about symmetric. Cool? Okay, let's see if we can look at number 2 here. Angle 1 equals 90. That's given. And angle 2 is equal to angle 1. Also given. Therefore, angle 2 has to be equal to 90. That's our favorite one. That's the transitive. We should call it trans now. Number 3, AB is equal to RS. RS is equal to WY. Then AB is equal to WY. It's the same thing as up above, right? It too is transitive. Number 3 is kind of fun. Number 3, all we did was multiply by a half, right? So AB is equal to CD. Then half AB is equal to half CD. We really are looking at reflexive. If 1 plus 2 is 110 and 2 equals 3, then 1 plus 3 is 110. We're back at transitive. RS is equal to RS. Well, we just reflected ourselves. Sorry about that L. If AB is equal to RS and TU is equal to WY, then AB plus TU is the same as RS plus WY. This too is transitive. We're almost there, guys. This is the last one. The last one, again, 1 equals 2 and 2 equals 3, then 1 equals 3. It says it right there. That's transitive. Right? A lot of transitive. And it's a big, big property in geometry. It's what we talk about all the time in geometry. So once we get this down, look at this. Out of the 8 problems, 1, 2, 3, 4, 5 of them were transitive. So must be pretty important. So thanks, guys. I'm going to hand out a worksheet for you guys to work with, and then move to the other side of the room and take care of the next class.